Glass fiber filled TPU might seem like a bit of a joke when you first hear about it. I remember first hearing about it a couple of years ago and thinking, that can't possibly work, can it? Well, can it? Let's go. This video is sponsored by PCB Way. TPU GF is exactly what you expect and nothing more or less. It is TPU with glass fibers impregnated into it. A lot of glass fibers actually, or a relatively high amount. This Soriatech TPU is 15% glass fibers, presumably by weight. If so, that translates to around 8% by volume, plus or minus a couple of percent, I guess, which is pretty funny because you can't see it. Even under a microscope, we are not seeing much of the glass fibers. You might wonder why, but actually the reason is pretty interesting. The glass fibers and the polymer seem to have very similar refractive indexes, so especially with the filament being black, they just don't stand out in any way. You probably wouldn't get this surface texture without the glass fibers though, so they are still affecting extrusion in the factory, and of course the overall feel and look of the filament definitely matches a glass fiber material. You can tell it's glass fiber, you just can't see the glass, if that makes sense. The other interesting thing about GF filaments in general, and I've always avoided GF filaments, which is my mistake until recently, because, well, if you've ever had a glass splinter, which you probably have, you'll know that fiberglass itself can be way more annoying than carbon fiber filament, but actually, weirdly, that's not the case for filament, or at least especially TPU GF. In fact, no matter how much you bend or break the filament, you really don't get the same splinters that you will see in CF filament under a microscope. It's funny because this makes glass fibers a relatively good match for 67D TPUs like this. They're both flexible. As a result, we avoid what we call friable fibers. So it's reasonable to extend that logic and consider TPU GF to be relatively safe to handle, even though on a personal level I do still find it mildly irritating to handle because the surface is still rough on a microscopic level, because obviously it's still got glass fibers in it. It's kind of like handling fine sandpaper to touch, I guess. And if you don't like this sensation, then you could try this stuff that Soriatech have also sent me, that I haven't actually found an application for yet, because I don't really care about the surface of 3D prints, but some people do. This applies to any filament. It's basically a urethane paint, so you'd imagine it would stick well to a urethane filament, but we'll try it. You can just paint it on or spray it, and it's supposed to give a smooth result. So about strength, I don't have fancy strength testing machines here. I guess I could do, but I think there's channels for that, and I'm more into macro stuff. That's kind of the speciality over here. The thing is, when it comes to stretching TPU GF, you'd think it would be possible to stretch the TPU in such a way that the plastic will effectively slide off the glass fibers internally, causing a permanent weakening of the material. That does make sense, and yes, that does happen, but not as effectively as you might think, because when you stretch a polymer, the material narrows, so it will grip the fibers up to a point when the material will finally slip, and then the fibers will become permanently ineffective. But of course, this won't happen all at once because it's a sort of chaotic process. In TPU GF, this actually takes more load than you might think, so it's probably only going to happen in situations where you've really pushed the limit too far, and in these cases, you'll be looking at permanent catastrophic failure. So the TLDR of that, I suppose, is that TPU GF is insanely strong, and it would be a pain in the backside to even test that because it won't behave consistently under load between samples, probably. So that's why I prefer doing macro stuff. But the set of properties that TPU GF gives you kind of moves you into nylon territory for a lot of practical applications, but not all of them, especially in the consumer market where we aren't calculating stresses and loads from a table and we don't necessarily know what to expect from nylon in the first place. At least those applications where you don't mind if the filament or the piece that you've printed gets a bit longer under load rather than failing. In fact, in a consumer environment, that's probably what you want. The principal advantage of TPU GF over nylon is that it's actually completely mundane to print. It will stick to PEI sheet a little too well, to the point where I would advise using glue just to get it off the bed. It doesn't warp at all because it's already above its glass transition temperature at room temperature, but also because it's flexible enough to just be able to sort of ignore stresses broadly, and it's happy to be printed at normal TPU 95A temperatures, unsurprisingly, because it's TPU. So it's ideal for consumer use. There's barely a printer on the market, especially consumer printers, that can't print this stuff due to it being 67D shore hardness, so it avoids a lot of the TPU problems, and that's abrasiveness notwithstanding. And yes, because of that abrasiveness, you probably want to use a hardened nozzle. It's not essential, but it's definitely advised because this stuff will eat through a brass nozzle in no time if you're printing any kind of volume of it. As much as I'd like to tell you that this is the ultimate wonder material and you can't go wrong with it, you should print literally everything in it, that's actually not the case. TPU GF shares a weakness that all other glass fiber filaments have. In fact, some of them have it worse than TPU GF, and that is layer bonding. The glass fibers introduce a material interface that disrupts layer adhesion, and the more glass you have, the weaker the interlayer bonding gets. Annealing might be something you immediately think of that might fix this, but actually no, that's probably going to exacerbate it for reasons beyond the scope of this video. This is a problem that will affect any glass fibre filament, and for that matter, carbon fibre too. You may, in fact, have come across it with carbon fibre filaments, although they do behave slightly differently. Solving this obviously isn't going to be possible without removing the glass fibres from the filament, and then you would just have TPU, and that would make this video entirely pointless, but you can somewhat mitigate it with two settings: line width and increasing the print temperature. Don't exceed the top end temperature of 270 degrees C because it's a hard safety limit. You do not want to overheat TPU. It's dangerous, in fact, but do increase the line width. I did find that just increasing the line width made a huge difference on its own. So that does kind of make a case for 0.6 nozzles, I suppose, doesn't it? If you do have a need to increase the layer bonding, I think the better thing is to design around it rather than trying to tackle it head on. There are more applications for TPU GF than you might think. Soraya mentions a lot on their website, but anything where you need nylon, don't mind it being a bit more flexible, but want it to not shatter if it's hit or dropped. That does point to drone parts, vibration damping, even custom belts if you want. I did test that out and it seems like it might work, even though I don't have any current applications for a belt. Or indestructible spinning tops, which I'll explain after today's sponsor segment, which is PCB Way. PCB Way can not only manufacture PCBs, which I have some examples of here, they are incredibly high quality, by the way, and you can get them with a frankly ridiculous number of layers of separate copper tracks that I should try sometime because I've only been doing double-sided so far. Not sure if you know this, but you can actually stack the PCB tracks up to 14 deep. Anyway, in addition to this, PCB Way can manufacture parts for you using CNC machining, and you don't even need to worry about figuring out how. When I entered the world of CNC about a year ago, I had a fun time discovering how even the simplest design, which would be really simple to 3D print, can be a complete headache for planning the paths and tools and steps, but with PCB Way you just upload your file and they will somehow magically figure out how to make that into a finished part for you. They also provide sheet metal processing, 3D printing, including resin, injection molding, and more. Go and have a look on their website, which is linked in the description, where you'll also find a coupon. Thank you PCB Way for sponsoring this episode. This is Denise's channel, and she is working with Prusa and open source, and this is to make some spinning battle tops. And, well, TPU GF is possibly the most hilarious material to try and use to make the contact surfaces of a battle top out of. I did ask her if TPU is banned, and she said no, TPU is fair game. I did actually make it whistle as well, because why not? We do want a spinning top that whistles. The Battletop version doesn't whistle as well, unfortunately, because RPM reasons, and I can't really figure out a way around that. The non-battle version really does whistle, and that can be printed in normal PLA. I'll share a link in the description. Have a go at it, because it's a really cool spinning top, and it spins for absolutely ages. I printed it in PLA and TPU using material interlocking, which I have previously made not one but two videos about, so if you want to know about that, go and have a look for those two videos. What this means is the parts are completely inseparable, literally inseparable. We've tested this. The materials will break before they separate. I printed them on the Snapmaker U1, which is obviously very capable of printing these two materials because it's a tool changer and because it's my favourite machine at the moment. But speaking of tool changers, I want to give you a heads up on something that's coming, but I haven't got a review machine yet, but I want to give you a heads up on it now because the information is out there. That's the new Sovol M1D. Sovol did contact me asking for an ad about this, but I don't have any space before they release it. So I told them, well, do you know what? People will want to know about this machine, so give me something to leak and I'll run with it. If I'm to describe the M1D in one word, it's going to be the word ambitious. For Sovol especially, this is several generations more advanced than the last multi-material machine they did. That was the SVO4 IDEX, if you have been around for long enough to remember that. They've obviously recognised that there's IDEX heritage that they have as a company that can be tapped into, and this machine is part tool changer, part IDEX, which is a little bit crazy, to be honest. If Sovol can pull this off, especially at this price, it will be an absolutely irresistible alternative to things like the H2C and Index. So you have been formally introduced to the M1D, and hopefully I will be doing a full review of that soon. I think TPU GF fills a hole in the consumer and industrial markets where nobody really knew there was a hole in the first place, but there definitely was. It is relatively indestructible as long as you accept the lower layer adhesion. It's flexible, but not too flexible, and it's actually not that expensive compared to many engineering nylons and materials like, for example, PBA. It is currently available from Soraya Tech in a wide range of black and black, and it's likely to stay that way. I did notice one other company also makes it. I can't remember who, but of course now that I've made a video on it, probably other companies are going to notice and start making it. And of course that's a good thing for consumers. I will stick links to all the resources used in the video in the description. You can let me know in the comments what you think about flexible materials with glass fibre in them. Should we ask for glass fibre filled PCB next? I feel like yes, we should. I'm not sure if it will work, but I think it would be cool. I will see you next time. Thank you for watching.